This is Bob Capetta from the University of Illinois at Chicago, and this is another trigonometric equation. So we want to solve cosecant of 3 theta over 2 equals negative 2, and theta is going to be between 0 and 2 pi. So how are we going to do that? We're going to remember, of course, that cosecant is the reciprocal of sine. So if I take the reciprocal of the left side, that'll give me sine 3 theta over 2. And the reciprocal of the right side will give me negative 1/2. And that's going to be much easier for us to solve. Now where do we go from there? Sine of something equals negative 1/2. We're going to need to think of a reference angle, and we're going to need to think of possible quadrants. So the first question we'll ask is, what is the reference angle? Well, what do we know? Do we know an angle whose sine is 1/2? And of course we do. The sine of pi over 6 is 1/2. Remember, the reference angle is always a first quadrant angle, always between 0 and pi over 2, between 0 and 90. So the reference angle here is pi over 6. And then we have to ask the question, where is sine negative? Well, sine is the y value in the unit circle. So sine will be negative when the y values are negative. So if you look at a unit circle, where would the y values be negative? In quadrant 3 and quadrant 4. So what I'm going to need to do is I'm going to need to find the reference angle of 1/2 in quadrant 3, quadrant 4 for the first part of this problem. So if I'm in quadrant 3 with pi over 6, what will that angle be? If I'm in quadrant 4 with pi over 6, what will that angle be? So we know our reference angle, we know our quadrants. So there we go. In quadrant 3, we have pi over 6 beyond pi, so all the way to pi, and then pi over 6 more. Remember, the reference angle is always measured with the x-axis. So for quadrant 3, it'll be pi plus pi over 6. Now how do we do pi plus pi over 6? Multiply across. Pi times 6 is 6 pi. 1 times pi is pi. So the numerator is 6 pi plus 1 pi. The denominator is 1 times 6. So we get 6 pi plus 1 pi, 7 pi over 6. So if I'm going from 0 to pi and then pi over 6, I am at 7 pi over 6. That is my quadrant 3 angle. What that's telling me is it's telling me then that the sine of 7 pi over 6 is negative 1/2. And we can see we want the sine of 3 theta over 2. That'll be helpful for us. Now what about in quadrant 4? We go all the way to 2 pi and then back up pi over 6. What will that be? It'll be 2 pi minus pi over 6. So how are we going to do this? 2 pi times 6 minus 1 times pi. 2 pi times 6 is 12 pi, minus 1 times pi is pi, over 1 times 6, and we get 11 pi over 6. So we know then, at least in our first revolution, that the sine of 7 pi over 6 is negative 1/2, and the sine of 11 pi over 6 is negative 1/2. But we may need more than one revolution. You'll see the multiplier on theta is 3/2. So normally speaking, our rule is we're going to need 1.5 revolutions, or we may need 1.5 revolutions. Let me go ahead and just do 2 full revolutions, and then we'll see which of our values are still between 0 and 2 pi. So to get my second revolution, I'm going to add 2 pi to 7 pi over 6. That'll give me a coterminal angle. Here's 7 pi over 6, go around again, 7 pi over 6 plus 2 pi. Same thing with 11 pi over 6. Here's 11 pi over 6, go around again, 11 pi over 6 plus 2 pi. That'll give me 2 revolutions for us to use to solve this trigonometric equation. So we have our revolution 1 values. Now to get our second revolution, we'll add 2 pi to 7 pi over 6. 7 pi over 6 plus 2 pi. 7 pi times 1 is 7 pi. 2 pi times 6 is 12 pi. 7 pi plus 12 pi upstairs, 6 times 1 downstairs. 19 pi over 6 is the quadrant 3 revolution 2 version. Quadrant 4 revolution 2 will be 11 pi over 6 plus 2 pi. 11 pi times 1, 2 pi times 6, 11 pi plus 12 pi, 23 pi over 6 times 1 is 6. The sine of this angle, this angle, this angle, and this angle all equals negative 1/2. And we're going to use that to solve for theta. because we know the sine of 3 theta over 2 equals negative 1/2. So recognizing that fact that we have those four angles that equal, whose sine equals negative 1/2, the question is sine of 3 theta over 2 equals negative 1/2. So let me go ahead and fix that. Looks like I have a typo there. So indeed that's fixed. So sine of 7 pi over 6 is negative 1/2, sine of 11 pi over 6 is negative 1/2, etc. But sine of 3 theta over 2 is negative 1/2, so I will need 3 theta over 2 equals 7 pi over 6. 3 theta over 2 equals 11 pi over 6. 3 theta over 2 equals 19 pi over 6. 3 theta over 2 equals 23 pi over 6. So this is what we have to solve. And what do we know? Sine of 3 theta over 2 is negative 1/2. Sine of 7 pi over 6 equals negative 1/2. Therefore, 3 theta over 2 should equal 7 pi over 6. Solving for theta, we'll multiply both sides by 2/3. 2/3 times 3 theta over 2 is theta. 2/3 times 7 pi over 6 is 14 pi over 18, which reduces to 7 pi over 9. And that one's good because it is between 0 and 2 pi. No problem there. Now let's take a look at our second answer from the first revolution. 11 pi over 6 should equal 3 theta over 2. So 3 theta over 2 is 11 pi over 6. Multiplying both sides by 2/3. 2/3 times 3 theta over 2 is theta. 2 times 11 pi, 22 pi over 18. Reducing that, and I get 11 pi over 9. Now, we went 2 revolutions because my multiplier was 3/2. Typically, we go the same number of revolutions as the multiplier. So, did I need to do that? Well, sine of 3 theta over 2 is negative 1/2, and sine of 19 pi over 6 is negative 1/2. Therefore, 3 theta over 2 is 19 pi over 6. Multiplying by 2/3 on both sides, 2/3 times 3 theta over 2 is theta. 2/3 times 19 pi over 6, 2 times 19, 38 pi over 18. Reducing that, and I get 19 pi over 9. Well, 2 pi is 18 pi over 9. So the fact is 19 pi over 9 is beyond my range. So I was only interested in values from 0 to 2 pi, so I will not include 19 pi over 9. And similarly, I'll show you for 23 pi over 6, if that's 3 theta over 2, the result is 23 pi over 9. Again, bigger than the range from 0 to 2 pi. And we're told that our answers must be between 0 and 2 pi. So which of my answers are between 0 and 2 pi? Well, the 7 pi over 9 and the 11 pi over 9. So in fact, I did not need to use the second revolution. However, when you have that multiplier, you really should at least go out that many of revolutions because you may need to have all of those values. So the answer to this question is 7 pi over 9 and 11 pi over 9. And that concludes this lesson.